Hi everybody. Mr. Wagner and I thought it would be a good idea to record a few videos to help you get started with your checkpoint 3 if you haven't done so already. So checkpoint 3 involves making a lot of models, and what I'm going to show you is making a Bohr model and a Lewis model of nitrogen. So before we get started, one thing that we highly recommend is that you complete this table in your checkpoint 3 slides if you haven't done so already. And after you complete it, you can check your answers here. This is a link that will go to a document that actually has this table all filled in. And this will help you tremendously in making your models. So I'm going to start with the Bohr model that's on the left. It's the more complicated one. But after you complete the Bohr model, the Lewis model is actually much easier to approach, I think. So the first thing that we want to do with the Bohr model is look at the element we're modeling. And again, in this case, we're modeling nitrogen. And the first thing that I like to do is determine the number of protons. So here in the middle, you'll see that in the middle of this red circle, which represents the nucleus of our atom. The Bohr model, this is the nucleus, and we have 2 rings in this case. And here, there's a space to put the number of protons. So we go look at our table, and nitrogen has this symbol N. We can just go across this row and see in this column for total number of protons that it has 7. And remember, the total number of protons, it's always going to equal the atomic number, regardless. That never changes. So here's the atomic number, 7, and that's the number that's on the symbol. And that's what this number means. This number means, hey, if I'm nitrogen, I've got 7 protons. So let's go back over to our Bohr model here, and we'll just put a 7 here in the middle. Now, the next thing I'm going to do is to label these rings, just as a reminder of what they are, and you should do this in all of your models as well. So the inner ring, we call that the core ring, and I like to think of it, it's like an apple. So the nucleus, the protons, think of those as the seeds of the apple. The core is just the part that immediately surrounds it, but it's on the interior. And then you have this outside part of the apple, and this outside ring is the valence ring. And valence just means outer. That's the only thing to remember. Core is the inner ring, and valence is always the outer ring. So, okay, we have those labeled. So the next step is to determine how many electrons there are that go into this model. So for this atom, if you read the prompt here, where we're creating this model of nitrogen, it doesn't say anything about the number of electrons. And if that's the case, what we assume is that it's a neutral atom. Neutral meaning it has 0 charge. And in that case, we can go back up to our table here, and you'll see there's this column, total number of electrons. And this is for all of the neutral atoms when there's no charge. And what you'll see is that this number of electrons, it always equals the number of protons. And the reason is that protons, they're positive charges. They're a positively charged particle. Electrons, they're particles that have a negative charge. So if there's 0 total charge, this is like a +7, and this is a -7, and they cancel each other out. So now we know we have 7 total electrons. And I'm going to just start a little text box here, just so that's something that we can refer to, so I don't have to jump back and forth between this slide and the other slide. You don't have to do this, and this is going to make it easier for demonstration purposes. So we know that we have 7 electrons to put into our model, and we have this electron bank over here. But how do we actually put these onto the rings? That's the next question. And again, we can go back to our table, because you may have noticed that there's 2 columns here after the total number of electrons, a core electrons column and a valence electrons column. And what you'll see is that all of these elements and all the elements in the second row of the periodic table, they have 2 core electrons. Okay, so let's just go back here and let's see, 2 core electrons. Now I'm just going to abbreviate electrons with an E, just to make it a little easier for myself. And then if we have 7 total electrons, and 2 of these 7 we call the core electrons, the remaining 5 electrons are the valence electrons. And that's how we get this number. It's just 7 minus 2 equals 5, or you can think of it the opposite way. The number of core electrons plus valence electrons has to equal the total electrons. So in this case, we have 5 valence electrons. So I will stay here. And you should always check this, that our number of core electrons and valence electrons, you add them up, this should always equal the total electrons that we have if you want a quick double check. And then when we fill the electrons into these models, what this tells us is that if there are 2 core electrons, then in this core ring or core orbital, that's where 2 electrons go. So let's start doing this. All right. And now we click on the electron and move it. And see, this is so annoying. Sometimes you just move the minus sign. I totally regret putting that minus sign there. I can't apologize enough for it. But if that happens, then just move the particle over. Don't worry about that stupid minus sign. Anyway, so we've got 1, and let's move the second one. I'm just going to put it over here. They can go anywhere in this ring for these models, so don't worry too much about exact placement. Okay, and we always work. The other thing about the Bohr models is we always start from the inside and work outward. So we fill up this core ring first with our 2 electrons, and now there's 5 electrons that go into this valence ring. Okay, and that's what the valence electrons means. It means that these electrons go in this valence ring. So if you've labeled your rings, then it should hopefully be pretty straightforward. All right, so we've got 1, 2, 3. I can see that's gonna, this is gonna move that stupid minus sign again. I know it. Yep, you see, that's okay. 4, and on that too, I'm just gonna 5. Okay, and that is our Bohr model. So we have our 7 protons. We have the core ring and the valence ring labeled. And we have 2 core electrons and 1, 2, 3, 4, 5 valence electrons to make our 7 total electrons. And that's it. So once we have the Bohr model, it's actually a lot easier to make the Lewis model. And I know this looks, there's not much here. It's just like a big X. But you'll see how we make this into something that actually has meaning. So the first thing we do is we want to change this X to the symbol for nitrogen. And if you don't remember that N is the symbol for nitrogen, the place you can go is always the periodic table. And we have this in your checkpoint document as well. And you can see that, okay, here's nitrogen right here. Symbol is this big capital N. So it's the first thing we do. We just change this to a capital N. And now the important difference between the Lewis models and the Bohr models is that this Bohr model, it shows all of the electrons, including these 2 core electrons. In the Lewis model, we don't care about the core electrons. So we only show the valence electrons. I'm gonna put this right here. Only show valence electrons, because that is really the most important aspect of the Lewis model when you think about making it, is that we do only show the valence electrons in the Lewis model. It makes it cleaner, it makes it simpler, and it's important for other purposes, which I'll talk about in a little bit. So we know from the table that we looked at, and which we wrote down here, that we have 5 valence electrons. But also keep in mind, if you've already made the Bohr model, then you can also just count the number of electrons that you have in your valence ring. And here again, we have the 1, 2, 3, 4, 5 electrons, and know that those electrons are the only electrons that we put into the Lewis model. So now it's just a question of, okay, we need to put electrons over here, and how do we do that? And just like with the Bohr model, there's a method to how we do this. So I've shared this with some people, but if you haven't seen this, one way to think about the Lewis structures is that here we have the symbol for the element. Again, I just represented it by the X because it could be any element. And we have these 4 positions around it, like down the top and the bottom and both sides. And don't worry about the numbers, just showing that there's 4 of them. And then each of these positions can actually hold 2 electrons. So it can hold a total of 8 electrons. And 8, it's a magic number. Now, I didn't mention it, but in the Bohr model, this valence ring, it can hold up to 8 electrons and then it's full. The small core ring, it can only hold 2 electrons and then it's full. But again, we're focused here just on the valence electrons. So we have our 4 positions. And when we put the electrons into the Lewis model, there is also, not quite in order, but is a certain procedure that we use, which is that in each of these 4 positions, and I'm just going to start at the top. You can start anywhere, but we put 1 electron into each of these positions before we start making pairs. Whoops. Okay, so remember, each of these positions can hold up to 2 electrons, but we only put 1 electron in initially, and then if we have more electrons to put in, that's when we start making the pairs. So we can put in these 4 electrons, and now we have to put in the 5th electron, and that one is going to make a pair somewhere, and it can go anywhere. I'm just going to put it here at the top. Move that. Oops. See, again, one of these annoying things. I just wanted to move that up a little bit, and these are all things that you might encounter, but you know what? That's good enough. So we have our 1, 2, 3, 4, 5 valence electrons, and if you have any doubts, this should be consistent with your Bohr model or the table that's on this slide. If they were talking about the neutral atom, keep that in mind. That's important. But that's our Lewis model. That's it. And the beauty of this is now it shows that we have these 3 lone or unpaired electrons here. 1, 2, 3. And those can go on to make bonds with other atoms to make molecules. And that's what our checkpoint 4 is all about. And then we have these 2 non-bonding electrons up here, we'll call them, or just call them pairs or lone pairs. We'll call them non-bonding sometimes because they don't make any bonds with other molecules typically. But that's it. I hope this is helpful for you. And again, if you have any questions, please feel free to reach out to Mr. Wagner or myself.